Thank you. Hello, everyone. So I am David Naughton, as Milena said, and I'm going to be talking today about a report that we've been building, one of many really we're working on at the University of Minnesota. And this one, I'll explain more about what this is, but as the title says, it's about continuously updated and available journal usage analytics. And so, about me, I'm a software developer. I'm the technical lead for our Pure project at the University of Minnesota, with which we branded Experts at Minnesota. And I work in application development for the University of Minnesota libraries. And I'm sorry, for some reason, I didn't put my email address in here, but I think you can contact me on the conference app, or my email is just my last name at umn.edu. And happy to talk with any of you outside of this and connect however we need to. And this is as you may guess, a picture of me on a bicycle here. I love bicycles. It's a lot of what I do in my free time, especially off-road riding on gravel and single track. So if you want to talk to me about bikes, I would love that. Or if you don't, I'm happy to talk about other things. But I think at dinner last night, I met a new friend from Denmark, and we talked about bikes the whole time. And I think we drove some people away because they didn't want to hear about it. So what are these analytics? This is actually for our use in the libraries. We call it our collections analysis report. And we want to get information about what journals our researchers are using. So thus our collections, journals that we are subscribing to. And the point is that maybe we're paying a lot of money for some journals that no one is using. And so we want to get some data to help us make decisions, are there some journals that we can cancel and maybe save ourselves some money, or subscribe to some other ones that maybe we're not subscribing to, but people are using heavily. And so we want to especially get data about not only what journals our researchers are using to publish their articles, but also in the citations for their articles, what journals are they relying on for that. And that's what makes this report a little bit difficult to build, because we can get information about the journals that the articles are published in from Pure, but to get that citation data, we really need the ISSNs for the journals. We can get that information only from Scopus. So we're combining data from at least two sources, from the Pure API and the Scopus API, and we actually already have a report that gives us this information, but we're working on replacing that report. And so here's why we're doing that. Here's the problem. So we have, the University of Minnesota is a pretty big university. I think we're one of the 10 biggest in the U.S. I think Andy was saying that. We call an R1 research university in the U.S. And our Pure we use for data for the entire university. So it's a lot. And this existing report doesn't do any caching at all. So when we want to update the report, that one re-downloads all the data. And it's hundreds of thousands of records. And right now, it takes at least 3 days to run. And the software that we use to build it, well, this is previous to me, but I'm saying we, I guess maybe I'm magnanimously taking some of the blame, but I actually didn't build that. But it uses a software that can only run, on a laptop. And so, a librarian has to run this on a laptop, and then the librarian's laptop is, tied up running this report until, for half a week, until the report finishes. And that's really painful, so we just don't run it very often. And so when I heard about that, I thought, well, I think we can do a lot better than that. And I think it seemed like a fun problem to solve for me. And so what we want to do instead is put the report on the web and continuously update the data, so and automate everything. And so this will just like automatically be updated all the time. It will always be available, for like anyone, on this website. And when I proposed this, actually, the librarian who does this analysis was kind of surprised. She kept asking me repeatedly, like, so how do I ask you to update the report? And it didn't seem to occur to her that it might be possible that you don't have to do that. It'll just always be updated without you asking. So how did we do that? Well, we didn't. At least yet. This talk proposal was aspirational. I was hoping that we would have this done and like we could show you what the new report looks like, but it's not quite done yet. But we are close to finishing, and I think we've learned a lot along the way, not only with this report, but our attempt to automate more of our use of Pure, which when I started on the project in like 2017, some things were automated and some things weren't. We were doing a lot of manual work. And so that's a lot of what I've been doing in general is just trying to automate all of it. And so we don't have to do that anymore. So some of the things we learned. So here's some things not to do. And a big one that I'll emphasize is to radically transform the data that's in your university or organizational system, for Pure. And why do I say that? It's because that the more you do that, the more difficult it is going to be to automate. And especially if you're representing data in a structurally different way. Like, if you're not, using your organizations like identifiers for like people or organizations or job codes, or maybe like we do, one thing that's been especially difficult is that, we chose not to put all of our organizations in Pure. And the ones we do put in Pure, sometimes we combine multiple university organizations into a single Pure organization. So that means we can't use like our university identifiers for those organizations. And it's been a manual process then to decide how we're going to represent those organizations in Pure and to make up identifiers for those organizations like that exist only in Pure and how they map to the university identifiers. And with all those manual decisions going on, it's impossible to update to automate doing things that way. And then because we're not automating that synchronization, and we don't have all the organizations in Pure, we also have more manual work to do because we'll discover when we try to add new people that, they work for an organization we don't have represented in Pure yet, and then so we have to manually add it to Pure. And so things like that have been, a real automation killer. I'd strongly advise against that, not to change like the structure and the identifiers of your data if you can help it. And I think in the interest of time, I'm going to skip the rest of that. There's so much I could say about that. But so another thing not to do, I think, is serial processing or doing things one at a time. And I put a little bit of like Python pseudocode in here to give you an example of what that might look like, even though this isn't real code and this isn't what we do. But I think this sort of approach is the most intuitively obvious to people, to just do everything for one record at a time before you move on to the next one. And it turns out that approach just doesn't scale very well. That's the biggest reason why this report takes so long to run, because like we're doing so much for each record. And even though we don't have like big data, when it's not that grandiose, it's big enough that that's why this report takes like 3 days at least to run. Let's say, here's another thing we did at first, and this was my fault. My first attempt at early on trying to get all Pure data into our local database is I tried to transform the data we got from the Pure API into a very highly normalized database schema, and to like represent everything that could possibly be in there. And what I love about the Pure data model is it's so rich and complex. There's like everything we could possibly need in there, but that's what makes it really hard to do that. And at least it was difficult, for me, it was too much being like the one technologist on this project. And it turned out to be really fragile because it was often difficult to know what data might or might not exist in a different record. Like not all the fields are always there, and sometimes there can be 0 to many subrecords, and so there are a lot of special cases to handle, and so that turned out to be a big pain point. So what might we do instead? We'll talk about what we did instead that I think like helped us to solve some of these problems. So again, going back to that first point, I found like as much as you can avoid big changes to the way you conceptualize data, like and represent data between systems, the easier it's going to be to automate. And then, of course, also process multiple records at a time. So for things like incurring like network I/O costs or like database operation costs, often the more records you can include in one operation, the faster it's going to be. So you don't have to incur those costs for every record. And so that means some things like not only bulk operations, but thinking in terms of things like mathematical set operations, which relational databases are good at supporting. For use of the API, or APIs, we do this for both the Pure and Scopus APIs, using parallelism, concurrency, or like asynchrony as a general term. And also going back to like instead of trying to load things into a highly normalized relational schema, what we've started doing instead is just loading the raw JSON data, into Oracle tables, like one table for each collection. And that way, and in the industry, like instead of the traditional like extract, transform, and load. Essentially what we're doing is we're extracting the data using the APIs, and then we're loading it, without changing it. And what that gets us is that, then it decouples the transformation from the loading. That makes the loading a lot simpler. We can be more sure that that succeeds, and then we can, transform the data later, as we need to. And I'll talk a little bit more about how we do that later. But of course, one of the caveats to all this is you can solve these problems, but some of the ways we've chosen to do it, again, it's not the most always intuitively obvious approach. And some of these things, can be pretty hard. And designing for automation can be hard. And like in our case, it was especially difficult because we had like so many manual processes that people wanted us to like automate, and that was, they were so complex. So that's a lot of our code, is devoted to that. That I'm trying to simplify and fix wherever I can. And one way that that can be hard is that sometimes people have strong opinions about that. Like in our case, it was a lot of again for the organizations, like the organization names in our human resources database are often short and cryptic, and people didn't like the way those looked in the Pure portal, and sometimes for financial purposes, we were combining lots of smaller organizations into one big organization in Pure. That seemed to make it look prettier in the portal. But I think that there are other ways we can solve that problem. I think we didn't really have to do it that way. We can make, and two of them are, we can make some organizations visible only in the Pure backend. They don't have to be publicly visible. And also, if we don't like the name of an organization, we can just change the name of the organization as it displays in Pure. And as long as we keep the university identifiers and use the same university organization tree structure, then we can still automate it. So it doesn't have to be one or the other. And then processing multiple records at a time. I've found just talking with other developers that parallelism, concurrency, asynchrony is not something that every developer is familiar with. So just getting a software developer, any software developer may not be all you need to solve a problem like this. And it seems like there's a lot of confusion about what those terms even mean. The developers in the room may recognize Rob Pike, a computer scientist who is one of the creators of Go, which is a language that supports asynchrony really well. And he has a great talk called Concurrency is Not Parallelism, trying to help developers understand these are not the same thing. And also, similarly, this is something that, another example is something that a friend of mine who supports research computing talks to me about a lot. He'll say a lot of his researchers will complain that oh well my code is running really slow. We need a more powerful cluster. And he'll tell them, well, no, you actually haven't written it to even take advantage of the multiple cores in your CPU. It's the way you've written the software is the problem. Not that you need a more powerful supercomputer. And not that these people are not smart. They're very smart. They're scientists, but it's just an illustration that this approach is not necessarily well known and universal among people who write code. And I love this quotation from Princeton Research Computing that I included on this slide. That's a common misconception is that simply running your code on a cluster will result in your code running faster. Clusters do not run code faster by magic. For improved performance, the code must be modified to run in parallel, and that modification must be explicitly done by the programmer. And if you haven't done it before, you may not get that. And here, I'm in the interest of time, I'm not going to read this quote, but I actually found some research about developers' knowledge and skill in using this approach, and research supporting that. It's not all developers know how to do this. And I think I'm also going to skip this. This is getting pretty technical, about tools to use to take this approach. But come and find me later if you want to hear more about that. I could talk a long time about that too. So a little more about the approach we've taken in instead of transforming the data and loading it into a highly normalized schema. Yeah, we are using an Oracle database. And so what we do after we load the raw data is we use the Oracle JSON API. And Oracle allows us to, that API allows us to combine JSON path, which if you're not familiar with it, it's like XPath, but for JSON. And it allows us to combine JSON path expressions with SQL. And then so what we do is, we will use that to build materialized views, of the raw JSON data, and then we can use, only the fraction of data that we might need for a report, because Pure contains so much, and that way we avoid the cost of trying to transform everything, and so we can be much more precise and economical in what we're doing. But when I first started on this project, the Oracle JSON API was not available in our version of Oracle at the university. And it's only a few years ago that we were able to do that if we wanted to use university infrastructure. But I think most other mainstream databases yet have similar features, so you could do other things in other databases too. So let's quickly talk about maybe some other challenges. And this one, a little feedback for Elsevier maybe, is that I don't like that the Scopus API seems to force you to use serial processing most of the time. So I'm not able to use asynchrony, as robustly as I'd like. And I can get more into details about why that is too. And also, I've found that the documentation for the Scopus API to be sorely lacking. I know what fields exist, but often both the field names and the values were acronyms or initialisms that I'm not familiar with, and so the only way I found documentation, or the only documentation I did find, was from an old Elsevier product, I think, called Cyverse, that I'd never heard of before, that just happened to have a lot of the same fields with better documentation. So hopefully that will help somebody. And another challenge is that I think just synchronizing data between systems is just an inherently difficult problem. And so, but again, I like this sort of work. As I was saying earlier, I find this fun, and so I like using my brain to try to solve hard problems. And so if you can find someone like me, that may be a good way to go. And again, your mileage may vary. We have a lot of data. I've talked to lots of people from smaller organizations, who have much smaller sets of data, so you may not run into the same scaling problems that we have. And also, if you do, I just heard from Lars yesterday that Elsevier is now building these integration systems for people. So if you feel like you're not up to this challenge, you may be able to hire Elsevier to do it for you. And let's see, I think that I have probably described most of this already, actually. But these are just a few details of what we've built so far. And I don't want to take too much time to leave some for questions. But yeah, we have async Pure API and Scopus API clients. And all of our code is open source. And so I've given the URL to the new repository, and you can follow our work there, share our work there. And we have some example reports we've built too, with the Oracle JSON API. And also, if we could get at this Scopus API data from Pure, maybe we could use the Pure reporting module to build these reports, and we wouldn't have to do this work at all. Maybe a future possibility. But that is all I have for you. Looks like I made it in time, and I think we have a few moments for questions, right?
Well, it's tech
All right.
Yeah, perhaps one or two. Any questions?
This is Surya from University of Texas Medical Branch. So
Yeah,
quick question, are you actually loading incremental data? How are you doing things?
Loading increment, yes. Yeah, so
Because you said you brought it down from 3 days to quicker, right? Like,
correct. Yeah, the way we're able to continuously update is we load like only new and changed records, and we delete records that no longer exist in Pure or Scopus.
and I'm guessing this is being done from the old JSON, old API, right? From
Correct.
the endpoint?
Yeah,
Okay.
yeah, because we're relying on the changes endpoint to get some information about what has changed in Pure, and that's not available yet in the new API. That's a great question.
Got it. Another question, like you mentioned ELT, right? You're actually loading it and then transforming it.
Yeah. Mm-hmm.
So, and you're using JSON path, right?
Yeah.
To query it. Are you querying it directly on Oracle? Like, where are you loading that
Yep.
data?
Yeah, we are.
Your ELT?
Yep. We are doing all that in Oracle.
So you're loading it where you have your employees and everything, like you're loading it to that database, and so that you can use the JSON path to actually filter it down at the source before you load it to your system for reporting purposes. Is that correct?
Yeah. So the one thing, I didn't mention is that what we're going to use for reporting is Tableau, and we already have like Tableau connected to our Oracle database. So as long as like we can build materialized views in Oracle that contain this data, we can just point Tableau at those tables and we're done.
Got it. Perfect. Thank you.
Mm-hmm.
Then I think I will say thank you very much.
Thank you. Thank you all for coming.